Okay, good day everyone. So this will be the recorded video for lesson 13. This is lesson 13, uh, data modeling in Power BI. I'll just change this one to 13. Okay, so that's 13. Okay, so for this video, we're going to understand the concept of uh, im- and importance of data modeling, learn different types of relationships in Power BI, explore key components of the data model, and recognize common best practices for building efficient models. Okay, so what is data modeling? So when we say data modeling, this is the process of designing relationship between data tables to create a logical and organized structure for analysis and reporting. So basically, it's like creating a map. So we are trying to create a map given our tables, and then we're going to uh, check the relationships between these tables. So the purpose is to organize data for accuracy, eliminate redundancy, improve performance and maintain consistency, and enable meaningful visualizations. Okay, so just think of a data model as a map that connects various places. In this case, our place is the table. So, without the map, you can still travel, but it's confusing and inefficient. So, however, with the map, if we have the model, everything is clear and connected. Okay, so what are the components of a data model? So, we have tables, of course, so contain rows and columns of data. So in the previous lesson, we have imported data sets. So those data sets are tables. So we have relationships. So these are the links between the tables. And we also have the keys. So keys are either primary or foreign keys. So these are unique identifiers. Then we have cardinality. So when we say cardinality, this describes how data in one table relates to one another. So it's either one to one to many to one, and many to many. Okay. So we also have the direction of relationship. So this determines how filters flow between tables. So what are the types of relationships? So we have one to many. So do take note of the symbols because we're going to make use of this. So we have one colon asterisk, that is one to many. So asterisk is symbolized by many. The number one is symbolized by one. Okay, so we have one to many. So it means one record in one table relates to many in another. So example for customer, and then we have to orders. So a customer is just one customer can have multiple orders. We also have the inverse, the reverse. We have the many to one. So many records relate to one record in another. So example orders, if we're in reverse orders, multiple orders can be related to one customer. We also have the many to many. So records in both tables can relate to many in the others. So students and courses, of course. So multiple students can have multiple courses. In the same way, courses can have multiple students. And then we have one to one. So each record corresponds exactly to one in another. So one employee has exactly one employee detail, or details rather. So it's 1:1. So relationship direction, so we have the single direction. So filters flow from one table to another. And we also have the bi-direction or both directions. So we have filters can affect both tables, useful but can cause ambiguity. So do take note that in our case for Power BI, we usually apply single direction by default for better performance and clarity. So we are gearing towards simplicity in this scenario. Okay, then we have star schema. So star schema and snowflake. So basically these are the two major schemas that can be applied in Power BI. So when we say schema, this is like a design. So, or yeah, it's a design. It's the flow of your data. So for star schema, we have one central fact table connected to multiple dimensions table. So take note, we differentiate the tables as the fact table and the dimension table. So we will discuss that in the next slide. So star schema is very simple, efficient, and it is always recommended for Power BI. So basically, when you do create data visualizations, it is preferable to have a simple and efficient star schema rather than having snowflake schema. But there are instances that snowflake schema is needed. So a snowflake schema, dimension tables are normalized into multiple related tables. So it's basically it's like an extension of a star schema. So this is more complex, harder to manage, but may reduce data duplication. So this is the diagram so that we can compare. So star schema is just like this. You have a one fact table. So fact table is basically, this is the central table, the main table, and then the other tables are just secondary tables. So they are dimensions. So for example, if we have, let's say, a sale, so sales table, so we can have here location, we can have here customers, we can have here products. So do take note that each dimension can also have sub-dimensions. If that happens, we have now a snowflake schema. So they are all connected, by the way, by keys. So either the foreign keys, so we make use of the foreign keys and primary keys here. So now, let's discuss about the fact and the dimension table. So when we say fact table, basically this is the table that stores quantitative data. So when we say quantitative data, it's numerical in nature, so measurable facts. So example, sales, revenue, orders, and expenses. Meanwhile, dimension tables, so if quantitative, if the fact table is quantitative, dimension tables would be descriptive, so categorical, context for facts. So example, customers, products, dates, and location. So those are the main tables present in our schema. So example here, if we have a star schema, so let's say we have a fact table here. So we have the item key, we have the time ID, we have the branch ID, we have the location ID, and then we have the quantity sold, amount sold, and average sale. So these here are quantitative data, diba? So the others, this one are just keys which will be related to the other dimension tables. So for item key, it's like a product key. So it's related to the item table here. So we have the primary key of the item key, of the item table. We have the item name, brand, sold by, and category. For the time ID, so we have here our time. For the location here, and then we have the branch. So basically, if you try to check all the dimension tables, they are descriptive in nature. So when we say descriptive in nature, they do function descriptively, categorically, no, sorry, not descriptive, but it's like describing, it's just categorical, uh, qualitative, okay, qualitative in nature. So meanwhile, if you look at the main uh, characteristics in the fact table, they are quantitative. So take note, fact table plus dimension tables is equal to insight. So it's like we are trying to arrange our data in such a way that it's easy to read. Okay, so it's easy for the Power BI to analyze your tables. So importance of relationships in Power BI. So it enables accurate calculation. So later on in DAX, on data analytics, when we code, we can actually use sum, average, and count if it's arranged properly, if the relationships is properly managed. And then we have ensure visuals show correct totals, allow slicing and filtering by dimension. So the reason why we separate this by dimensions, because we can use the dimensions for filtering. So, and create consistent and meaningful dashboards. Okay, now, your Power BI can actually auto-detect relationships. So, auto-detect, Power BI can automatically create relationships based on matching column names and data types. So, that's why it's also important that in the raw data, in the source data, it's already cleaned, it's already transformed in such a way that the keys are uh, clearly present or clearly labeled. So, para it's already easy for us to manage the relationships during data modeling. So, we can also do manual. So, for example, if we want to change later on, we want to insert certain uh, relationships within the tables. So, you can define relationships manually via model view, manage relationships, then we create a new. Then we need to choose columns, cardinality, and direction. So, best practice, always review auto-detected relationships to ensure accuracy. So let's try to understand cardinality, because this is the main focus of our discussion, because usually this is the thing that that makes the data visualization process difficult. So of course we need to review this. So if we have one to one, so take note, one to one is not common, it's less common. Each record in one table corresponds exactly to one record in another. So this is often used when separating detailed attributes or extending an entity into another table for performance or privacy reasons. So this is not common, but it can help you organize data without redundancy. So it can happen when you are considering privacy concerns within the data, but most often times, in our case, in our lessons, or even in our activities, we might not encounter one-to-one relationships or cardinality. So we have here the one-to-many. So one-to-many, we have one star. So this is the most common relationship or type in Power BI. So why this is the most common relationship? So take note, star schema is the most used schema. So there is a centralized table, which is the fact table. So that's one. Then it can branch out to many dimension tables. So many. So that's why it's the most common relationship type in Power BI. So it typically exists between a dimension table, one side, and a fact table, the many side. So one record in the dimension can correspond to multiple related records in the fact table. So this setup enables effective filtering and aggregation across related data. Then we have the many to one, the reverse, of course. So reverse of one to many, multiple records in one table related back to a single record in another. So it's often automatically recognized when relationships are created, and it's functionally the inverse of one is to many. And then we have the last one, many to many. Records in both tables can relate to multiple records in the other. So common in complex data sets. So especially if we have tagging, like even enrollment and categorization system. So we might encounter this later on when we have multiple tables. So take note, many to many will happen if we have multiple, like it's really a lot of tables compared to uh, simple star schema. So many to many is present when we have snowflake schema. Okay, so to manage this properly, use a bridge or junction table that holds unique key combinations, ensuring relationships remain clear and calculations stay accurate. So basically, there is a junction or a bridge table in which the bridge contains the foreign keys. And then that table will have a key which will be connected or be related to the fact table. So it's a dimension key with multiple foreign keys. So Let's have an example or examples for each cardinality. So one to many, so customer to orders. So one customer can place many orders, but uh, orders, take note, orders can only have one specific customer. Di ba? You cannot have a multiple person for one order. So many to one, so orders, so it's the opposite. So many orders belong to one customer. Okay, so yeah. So how about for one to one? So one to one, so again we can have one, what do we call this? One student for one student, then one student detail or details. For what else? Many to many. So we have multiple. What can we have an example of that one? Mm-hmm. Ah, students to courses. So students can have multiple courses, and of course courses can have multiple students. So that's many to many. Okay, common modeling errors. So circular relationships. So we should not have like this. So A is related to B, B is related to C, and then C is related to A. So as much as possible, the modeling should be from inner to outer. So it should start sa center. I cannot see the. So it should start sa center, then it's going out. It cannot have a relationship in which the last data would be related to the inner. So it should be outwards. Okay. So ambiguous filter direction, and then missing keys or inconsistent data types. So we need to check that one. Many to many relationship without bridge tables. So again, if you have many to many, you should have a bridge table. Over normalized table slowing down performance. So when we say over normalize, we for example in one to one, if we can actually integrate one to many, so just integrate it to one to many. So yeah, that's the common modeling errors. For the data model view in Power BI, we have 3. So in similar fashion that Power Query has 3 functions, data model view has 3 functions also. So we have the report view, we have the data view, and the model view. So for the report view, we create that's the part in which we create the dashboards. We see the data visualizations there. So I'll be discussing this one during our lab time after the midterm exam na lang, so that we can see the app itself. So for now, let's just have the concepts lang sa. So data view, inspect table contents, and then model view, which is the topic today. So manage and visualize relationships in model view. You can drag and connect fields between tables to define relationships. So this is the model view. Okay, so of Power BI. So it's this icon here. And then you can see we have the data tab here or data panel. And then under the data panel, you have the tables and the model. So you can actually see the different categories. So we have the tables, the roles, the relationships, so the measures, so on and so forth. So we will actually do this when we have the lab. Okay, so but basically it will look like this. So if you try to look at our table here, we have a center table here, which is the fact table. So the others are just dimension tables. And you will see there are asterisks and there are ones here. So meaning this is, for example, this is one to many, and you will see the direction. That's one to many. This one is one to one. So it's very easy to read as long as you know the symbols. So of course, it will contain the keys, the primary keys, and the foreign keys. So best practices for data modeling. So as much as possible, if we can use star schema, we use star schema. Okay, so the simple, the better. So, name tables and columns clearly. So, again, we will use human language when we try to name tables. And then, for the key, so we can codify the key if necessary. So, ensure unique keys exist for relationships. So, avoid bidirectional filters unless necessary. So, if you try to go back here, so we only have bidirectional. You will see it's bidirectional if the arrows contains two arrows, two opposing arrows. So, most of the tables here are unidirectional or one directional. So, usually bidirectional relations or filters happens if you have one is to one relationship. So remove unnecessary columns before loading. So if it's not needed, sorry, if it's not needed, so just remove the columns because uh, it also consumes space in our data model. So the lesser the size, the lesser the space of the model, the better. Okay, so use data tables for time intelligence. So we will have this one later on. Date tables. So take note, there is a specific table type. So you can actually change the type also. For example, here we have the date here. Power BI provides special tables so that it's much easier to process your data. So you can use date tables for time intelligence. So basically for tracking using time. Document relationships for future maintenance. Okay, so that's the end of this lesson. So it's just a short video. So please do answer the forms I provided in your MS Teams. So take note that the deadline is still after midterms, but if you can answer it today or during the time that this video is posted within the day, then you will get a bonus point for the exam. Okay, so that's all. Bye bye.